Okay, let's unpack this. Today, we're diving into two really powerful, but sometimes kind of subtle AWS networking bits. Elastic IPs,
Uh,
EIPs and Elastic Network Interfaces, ENIs.
yeah, you probably hear those terms thrown around.
Exactly. But we want to get past the jargon, really show why these tools matter for building cloud services that are actually consistent and, well, resilient.
It's interesting, isn't it, how these almost hidden pieces are like the backbone for a lot of the reliable stuff we build.
Totally. So let's kick off with Elastic IPs. Uh, think of an EIP as basically your application's permanent public address on the internet.
Right, because the default public IP you get with an EC2 instance, that can change.
Yeah, if you stop and start the instance,
Yeah.
poof, new IP,
Mm,
which is often not what you want.
definitely not. An EIP, though, is static. You grab it for your account and it stays put. It's yours.
And that consistency is
Yes.
the key, right? It
Mm.
means your web server, your API endpoint, whatever needs a fixed public face has one.
Precisely. It separates that public identity from the actual EC2 instance underneath, which might come and go.
And that helps with high availability too, I imagine.
Oh, absolutely. If your main instance fails, you can just quickly point that same EIP to a backup instance. Minimal fuss.
So the problem EIPs solve is that unreliable default public IP. They give you that solid, predictable address.
Exactly. You reserve it in your account, and then you can associate it dynamically with an instance or even an ENI. We'll get to those in the same region.
So like if my web server instance dies, I launch a replacement.
And just remap the EIP over. Downtime is minimized. Users probably won't even notice, ideally. The DNS points to the EIP, and the EIP now points to the new healthy instance.
Okay, that makes a lot of sense for the public-facing side. Now, ENIs, Elastic Network Interfaces, these feel a bit more intricate.
They are, but they offer incredible flexibility. Think of them like virtual network cards, proper network interfaces you create in your VPC.
Virtual network cards.
Okay.
And you attach them to EC2 instances.
Yep. You can attach them, detach them. They configure things like private IPs, security groups, and you can even associate an EIP with an ENI.
Ah, okay. And the crucial part is they're independent of the instance.
That's the magic bullet. An ENI exists on its own. The instance can be terminated, but the ENI, with all its configuration, its private IP, its security group rules, maybe an EIP, it sticks around.
Why is that so useful?
Well, it unlocks a lot. You can attach multiple ENIs to one instance. Imagine needing separate networks, like one for public traffic, another completely private one for database access.
Okay, yeah. Different security rules for each, maybe.
Exactly. Or maybe you need multiple private IPs on a single instance for some legacy application. ENIs let you do that.
And the failover aspect.
That's huge because the ENI is independent. If an instance fails, you can detach the ENI and attach it to a standby instance. All the network config, the IP addresses, security groups, the EIP moves with it.
Wow. Okay, so you don't have to reconfigure the networking on the new instance. You just move the whole network personality over.
Precisely. It makes failover much smoother and faster. Think of that web server again. One ENI for public traffic using an EIP, another ENI for secure back-end communication. That's a common pattern.
So bringing it together, EIPs and ENIs.
Hmm.
You mentioned you can associate an EIP with an ENI.
You can, and that's often the most powerful way to use them together. You attach the EIP to the ENI and then attach the ENI to the instance.
So you get the static public IP from the EIP and the flexible detachable network configuration from the ENI.
Bingo. It tackles both problems, the dynamic public IP issue and the limitations of the instance's default networking. You get stability and flexibility.
Which you need for anything serious, really. Scalable apps, fault-tolerant setups.
Absolutely. It means you can swap instances in and out, handle failures, manage complex network setups, all while maintaining that consistent public access point and internal configuration.
Like with load balancers, maybe. You could shift ENIs with their EIPs between instances behind a load balancer during updates or failures.
That's a great example. It allows for really seamless management of the underlying compute resources without disrupting the network identity or flow. What's really striking when you dig into this is how these components, which seem quite technical, almost like plumbing, they're actually the things enabling these incredibly complex, highly available systems we rely on.
Yeah, they're the unsung heroes.
Which really makes you think, doesn't it? How could really understanding these building blocks change how you think about architecting for reliability in your own cloud setups?
That's a great question. It's like knowing how the foundations are built lets you design a stronger building, right? For anyone listening, maybe the next step is just logging into the AWS console and trying it out. create an EIP, create an ENI, attach them.
Yeah, that hands-on experience often leads to those aha moments. See how they connect?
Definitely worth exploring.